Alright.
Jesus bless.
Yeah. So pointers. How do I start? The whole point of pointers is that you don't want to pass in the information, you want to pass in the actual storage, right? So if I were to draw it out, let's say that this is main, right? Oh lord, everyone joined in all of a sudden. And then we have some extra function here, right? That's a function. So actually, we can just do that right now over here. So let me just remove all of this. I have it saved later elsewhere, so it's fine. So we have this whatever here, right? And let's give it two numbers: int a, int middle, and int difference, right? So this is going to. I'm going to fucking ban one of you. So all of this is going to do is we want two different numbers, right? So we have some middle number, and then two difference. This is the difference, and this is value A, this is value B. So this is the sort of issue that they want us to use pointers for. We have two numbers that we want to give back.
Yeah.
Right? So let's just call whatever 5 with a difference of 2. And so we take this, we do middle, or sorry, we do two integers, int a, b. So a is equal to middle plus a difference, and b is equal to the middle minus the difference. Now, if we just were to say pass regular numbers in, so let's actually define those integers here. Int a, b, int a, int b, and we can remove that. And we go printf these two values. You'll notice, oops, int a is equal to 0, int b is equal to 0. You'll notice this doesn't do anything. Because what's effectively happening here is that it's telling the information to the other function. It's not transmitting the same thing. So say if to give an analogy, this is the main and this is our function, right? And when we call it, we give this information, right? We give, say, the variable a, whatever's stored in a, right? So that is 0.
Oh my god, bro.
Oh, hell no, man. What the fuck, man?
And so function will take this number, right? It'll edit around, you can add, you can subtract, you can do whatever, but this doesn't change the actual variable here. It's just transmitting the information. So say if you're holding a piece of paper, this is you with a piece of paper, telling someone else some information, this is you basically saying what's on the paper. The paper says hello. And that person can take that hello, he can write whatever on another piece of paper, it's not going to change. What pointers do, as this analogy, it doesn't just tell what's on this piece of paper, it just straight up gives it to the other guy. So now this guy can make whatever changes he wants, and then he'll give it back. So that's the core of the pointer. So if this is some piece of paper with the number 5 on it, this paper is a pointer. This number here is your variable. So that's a difference between the pointer and the variable. So if we now change this into a pointer, right? Integer pointer. So that's a piece of paper with a integer in it. Let's read. Oh. And so we give that piece of paper, which we write as the AND symbol, right? The AND symbol takes the variable and then gives back the paper on it. And then we'll fix that. We can now see it works properly, right? Because instead of just giving the number to the other person, we're giving the actual piece of paper with that information for him to change. Does that sort of make sense, or did I lose someone there?
No, I'm
That
just
makes sense.
thinking.
Yeah, so that's the purpose of pointers. And there's a lot more uses for it than just returning more than one value from a function, but for now that's what we're using it for, right? So whenever you want to return more than one value, you use pointers. So if we look here, let me just take a screenshot so I can draw out what is actually happening here. So this is our code here. This AND, let me draw this in red so it's easier to see. This AND takes this number here, which is 0, and gets a paper on it, hands it here. This function changes what is written on the paper with the information. And so because it's the same piece of paper, it's now stored in here. So again, that's just how pointers work. And this is something that I would recommend you get used to. To read the code and tell what's going on. Because
Can you repeat that again, please?
What?
Sorry, can you repeat that again?
Oh yeah, so what's going on here is that we define two variables here, right? Int A, which is 0, and int B, which is also 0, right? And everything that is written needs to be stored on a piece of paper, right? So what this is doing is saying, take this 0 and get me the paper that it's written on. And same thing here. Get me the paper on which this 0 is written. So it hands it off to here. These two. And what this says, when we have a star on a pointer, when we do star of some pointer, this means get me the variable. So, when you see AND, or I can't draw AND of some variable, this says get me the paper pointer. And whenever you see star of a pointer, that says get me the variable. So these two should be sort of like the automatic translations when you see these characters. So function whatever, give it 5, 2, the paper on which 0 is stored, on which A is stored, and the paper on which B is stored. So it comes into this function, whatever, and once again, it's saying here, get me the variable stored on this paper A, right? And write into it, middle plus the difference. Our middle is 5. Our difference is 2. So 5 plus 2, it comes over to this paper here and overwrites it. 7. And it does the same thing here. Star B, which is get me the variable of the pointer B. So get me what's stored on this paper. Middle minus difference. So that's 5 minus 2, or 3. And because we're modifying what's written on this paper, this redefines what A and B is. And so we print out A and B. That's 7. That's 3. So is that clear, or did I lose someone?
No, you got it. But so basically, it doesn't matter what you set A and B as, because you're gonna redefine it after you do the whatever difference thing.
Yeah.
Okay, cool.
The reason why I wrote 0 here is just to make it more clear, because if you don't define it at first, it will just use whatever happens to be stored there at any time. Like if I just define A and B and print it, you'll get some weird ass values. Because that's just what happens to be stored there at that moment in the computer. Pretty much weird computer shit. So you have to define it, or else it's going to give you a weird number. At first, anyway.
All right, cool.
Yeah, so, again, let's compare this to if we didn't use pointers at all. what happens when we just do this? So I'm going to take this, put this here. So what happens here? So we give A and B, which are 0. So our int main is telling it, hey, A is 0 and B is 0. So this is 0 and this is 0. It's just telling the information. It's not giving it the paper. So this function here will overwrite with whatever it wants. It'll write this is 7, this is 3, but they're different. It doesn't transfer over because this has a paper written 0 and this one is 0, but they haven't been changed because you're just telling it what these values happen to be, not giving it the information. So in other words, this is copying over that information to a separate A and B. These are two different A and Bs. So that's why we use pointers. And when you do that, you start to see why we do all the other stuff for, say, lab 5. So let's look at lab 5 here. Let's go over number 2 because a bunch of people wanted me to go over that one. So this is my code. Obviously, don't copy it word for word. So here, let's see, time to moon. So we give it the speed, we give it 2 pointers. The paper on which minimum time is written, and the paper on which maximum time is written. And we do exactly what I showed there in the previous example. So here we have the speed. We calculate the minimum time, and we store it onto this paper that we have here. We replace the variable with that. And we do the same with max time. And we kind of, just a note, we do need this star here, because if we remove that star, what you're saying is replace the paper with, let's say, in this case, 7. So that doesn't really make too much sense, at least not now. It will a bit later, but this will still be wrong. So that's why we have this star to say replace the variable stored on the paper. With 7. So again, I just really want to hammer in how pointers work, because that's something that you just really need to be comfortable with, or else you'll start tripping over yourself all the time. So I'm gonna mute you, Dedicated Hamburger King. So yeah, we can use this to return as many extra variables as we want. So there's that. That's the main thing that I think more people will get mixed up on. The second one that I've been asked to go over is how you go through these questions, right? What is the thinking rationale? And in short, what I think a lot of people have a lot of trouble in. So this is your thoughts, right? You start with your thoughts in your head. So let's start with the first question from this lab, because it was probably the easier one, in my opinion. So how this thought works is that we want to make a function, right? Make a function that gives back the 3 values in increasing order. And what I see a lot of people do that really makes them trip up is that they go directly from this into C code. And when you do this, you have to worry about the algorithm. you have to worry about how do I turn this thought into a set of instructions that an idiot could follow, and then you have to turn that into syntax, and then you also have to debug to make sure it works, and then you also need to do, actually the math comes before that, but you do the algorithm, you do the math, you do the syntax, and then you make sure that what you're typing is correct directly into C. This, you'll eventually get used to it, and eventually you'll just instantly start turning your thoughts into code. But when you're new to programming, this is incredibly hard. And when you keep on trying to do this, it's pretty much just hitting your head against a brick wall. Don't do this. You should not be turning your thoughts into C code in one step, is what I'm trying to say. So, instead, turn it into steps. The first part is algorithm, right? And what we like to do is we like to say what's called pseudocode. Okay, what's the difference between code and pseudocode? Pseudocode isn't actually code. It's just simple steps that an idiot could follow. So, let's see. Make a function that gives back 3 values in increasing order. So we start with 3 numbers, right? So we say, first, have 3 numbers. Let's give them names. num1, num2, num3. If you pay attention, you can look at this and you can go, oh hey, this is integer num1 is equal to 0, integer no yada yada. But let's not worry about that for now. Let's just make something that we can understand a lot simpler than just raw C code. So we start with this first instruction, have 3 numbers, num1, num2, num3. And what I can do here is I can say, well, let's say that this is 5, this is 3, this is 2. So this is in completely wrong order, right? We can compare this first one to the second one, and if it's wrong, switch them, right? So if num1 is bigger than num2, swap them, or switch them. Right? Simple instruction, right? We can understand this. It's a lot simpler to read and write than raw C code because we don't need to worry about getting it exactly right for the computer not to complain to us. And so once again, so let's simulate that with these numbers. We swap them around. And by the way, this is also another great skill you should get used to. You should be able to look at instructions and sort of see how they will flow out. Basically be the computer, right? So once again, we look at this and we say, well, this is wrong. How can we fix this? And we can see, well, 5 is bigger than 2. It shouldn't be. So let's repeat that same step. So step 3. If number 2 is bigger than number 1, or if number 2 is bigger than number 3, switch them. And once again, we'll swap it. God, how do you disable soundboard on this? And then, once again, we could see these two are different, right? Or these two are wrong, right? And we could swap it again. If yada yada yada, you get the deal, right? Again, this doesn't need to be exact. This needs to be something that you can easily understand, easily write. Don't worry about C for now. And now, we can see we've made this fictional example, and we've been the computer, and we have solved it ourselves using this pseudocode. We haven't even touched C at all. So we don't need to worry about syntax. We don't need to worry about that stuff. And once again, now that we have the pseudocode, we can debug it. So we can throw any random set of numbers here, and then we can run through these lists of instructions ourselves and see if it works, right? And that's something that you'll also have to do as a programmer. You'll probably see it in future labs. You're asked to find what the problem is, or if there even is a problem, and also make sure your code doesn't have problems. Because if it does that you're unaware of, you get docked marks. So make sure to think of all of sort of weird examples that you might come across, and make sure your pseudocode works. So now we have made our algorithm, and we've also debugged it in 2 steps now, not in 1, right? And now, at this point, we can now turn this into C code. And you can see, yeah, I did do it very slowly, but I think I want to make it like a point that this is a sort of algorithm in your own head, right? You take it slowly, don't rush through it. Go through the problem and take it 1 step at a time. And then finally, this isn't actually Paint, but yeah, pretty much. I'm doing pseudocode on a Paint tab. And then finally, you can turn that into C. So I'm going to leave this last step up to you all, or else I'm going to be doxing my own code. But you can see how this sort of step, how turning pseudocode into C, turning this into C, is going to be a lot easier than make a function that gives back 3 values in increasing order is to turn into C. Why did I do a million if statements? Yeah, honestly, here's the thing. I'm not teaching you how to make the most optimal code. I'm teaching you how to get a code working. That's really the goal now. Later on, you can worry about getting it better. The first step is getting it working. Teach heap sort. I forgot how heap sort works. I'd have to search it up, but that would require arrays, and I'd have to explain arrays. Yeah, we did do sorting algorithm at start of the year, right? So we just got to the pseudocode part. And you should get used to that. You should, honestly, if you see an example of something that could be broken down into steps just in your life, I would recommend you start thinking about it. Think about how you can turn any problem into a set of stupid steps that any idiot could follow, pretty much. And at any time, if you have an instruction here, for example, switch them, and you're like, I don't know how to turn that into C, right? Well, here's a great thing. This itself is an instruction, right? This is a thought. Take 2 numbers and switch them. You can trust us with the code, let us add it. This itself is its own thought, and now we could turn this into pseudocode as well. So for example, if we have 2 numbers, num1 and num2, how can we switch it so the value at num1 and the value at num2 are switched? And again, we could break this down into code. We can go, okay, well, let's have num1 set to num2. So this was our original numbers. Num1 is now 4, and num2 is now 4. And now we go, oh, wait a minute. We no longer have access to the 7, right? Because that was the original value. We don't know. We can't switch num2 to num1 because now it's just going to be 4 again. So, okay, let's store that number 7 into a new variable. Let's go have temporary variable temp. And then we could set that to num1. So 3, set temp to num1. And then 4, have num1 set to num2. So let's restart this scenario again. We start num1 is 7 and num2 is 4. We have this temporary variable, and we set temporary to num1. So now temp, let's actually write this on side. So we have num1, num2, and temp. So num1 is originally 7, num2 is 4. So now we set temp to num1. And now we have num1 set to num2. So we set like this way. And now num1 is 4. Is temp function? No, it's a variable. So let me rewrite that. So temporary variable temp. So, and then now we can make this fifth step because we now need to set num2 to 7. We already have 7 in our temporary, right? So 5 have num2 set to temp. And now we've swapped the two variables. So you can see how we started with this single idea. Oops. Make a function that gives back 3 values in increasing order. We've broken it down into simpler steps. And then while we are breaking down the steps, sometimes we would have a step that was also not broken down enough. We think it's simple in our head, but then we go to write it down in C, and we're sort of like, how do we do that? Now I'm lost. Repeat the same thing, right? So now we go over, we make this into an idea, we write the pseudocode, and now we can turn this into C. We take this back and restart it and fill in this sort of instruction that we didn't know how to do with our newfound C code. So this is the strategy called divide and conquer. I think they said it in CPS. I was probably sleeping. But this is the sort of idea that they want you to do with pseudocode. And trust me, it feels slow, it feels annoying, but once you get used to it, it's going to speed you up a lot, and then eventually it's just going to be automatic. You aren't going to even need to think about the pseudocode. C will be your pseudocode. But until then, you're going to have to write in pseudocode. Is there anything that... Oh, pseudocode. It really doesn't matter, but it is PSEUDO code. That's how I spell pseudo. I don't know why that's the term for it. That's just what they call like code that isn't actually code. So is there anything like else that anyone wants to go over, or anything confusing about this?
Yeah, quick question. So let's say you're writing the code for this, right?
Yeah.
How would you make it stop when it reaches like the right, like when it organizes it? Would you just do an if statement?
Sorry, how to make it stop when you what?
Like let's say you have 3 numbers, right? And then you organize them. How would it know when to stop after it's organized?
Oh, are you talking sort of like Oh, are you talking this scenario that I've been writing out here, or just in general?
Yeah. In general, for example. Or sure, this scenario.
This scenario, well, this one we sort of brute forced it. We've done it in exactly 4 steps. So, say if it's 1, 2, 3, we don't really even check if we need to stop. We just do these 3 steps anyway. They don't actually do anything, right? It's going to be 1, 2, 3 at the end. But we don't need to worry about how much we have to go, how much we don't need to go. If you're talking generally, right, and this applies especially to sorting, right?
Mm-hmm.
Because what usually happens in a sorting is you have this while loop that you do the sorting here, And you do this again and again and again and again. At some point, you need to stop, right?
Right.
One way, and the most common way that I've seen it, is that you have some integer stop, or let's say sorted is equal to 1. So for other people who've done other languages, this is a Boolean. We're going to treat this as a Boolean. Sorted is equal true. Right? So we're going to enter this assuming it's sorted. Right? Actually, this should be inside. So we go into sorting, assuming it's already sorted. And then if we have to sort it, if we have to swap two variables, right? So if we swap numbers, this tells us we're not actually done yet, right? So we can go, okay, we're not sorted yet. Sorted is equal 0. So we could say, let's just work with Booleans for now. It's a lot simpler on the eyes. Sorted, true. So we start with the assumption that it's already sorted. And then as we're sorting, if we come across that it's not actually sorted, we say that sorted is false. We're not sorted, right? And then at the end, we just check. So if we are sorted, leave. So you'll end up seeing this sort of idea a lot for are we finished yet, pretty much. We basically yell, are we finished yet? And then we go through it. We go, oh, we're not finished yet. We have to go back. And then at start, we go, are we finished yet? Oh, we're not finished yet. We have to go back. And then we go again. We go, are we finished yet? Oh, we are finished. We don't need to swap any two numbers. Leave. Basically, be the annoying child that yells, are we finished yet? Sorry, does that explain, or?
Yeah, it does. Thank you.
All right, yeah. So I also want to go over, if there's no other questions, I also want to go over one set of problems that was given to me by my TA. So I did post this in the lounge earlier, or sorry, not the lounge, in CPS188 earlier. My TA also forwarded to all the other TAs, so I don't know if you also got it as well. Your TA would have to send it to you. Gave us this question to help us understand pointers, Boy said. Minor issue, I haven't looked at it yet. We're gonna figure it out together. And so I'm hoping this is I guess a nice example to show you how to think about these problems. So not just writing out the theory, but actually doing it in practice. So the intent of the self-guided hands-on micro lab is to help you see where you are going on, or what is going on behind the scenes when you use pointers. So read the instructions, examine the code. For each question, examine the code, try to answer the question, put your answer to the blank, uncomment the code that follows, run the code, see if the output is what you expected, whether right or wrong, do you know why that is the output, and leave each printf uncommented as you go. So, let me see. Here's a clean copy of the code for reference. Don't run this until you've tried the questions. Honestly, oh, this is This is this is given by my TA. So my TA cooked this up by himself independently. I'll post it in the chat again. There's nothing like extra outside of it that you really need to know. I would recommend you try doing this yourself, because what he is trying to encourage here, and what I really recommend you try as well, is that you try to be able to look through code and understand how it works. So you don't even need to run it to tell what is happening, right? Which in theory, is not really that hard. If you have a problem like this, you just start at the int main, you go one step at a time, down, 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 down. You jump up, do the work wherever, and just keep it. Is it sent every week for each topic? No, this was only sent this week. I would show my email, but I don't want to dox myself on stream. Let me see. Is there any incriminating information here? I don't see any. Okay, so here you go. So yeah, this is my TA, and he just attached the micro lab for anyone to listen. Everyone's got their hobbies in their free time, right? I just gotta make sure that nobody else finds out about them. So, yeah, he included the lab. Well, this one's broken. I sent in the proper one in there, and yeah, he says pretty much the same thing that I was saying. Pointers are the most challenging part of C. So make sure you understand pointers pretty much. And again, I would recommend everyone try and do these questions yourselves. I think it's better if I don't... Do you think it's better if I actually do this on stream, or I let you guys do it yourself? I should stream a game. Yeah. I'd say you guys should probably go and try it for yourself. But you'll see a lot of... Again, try working with pointers, try understanding how they work. I don't know if there's too much I can offer other than maybe try some online C examples. I've been... Can you record if there's anything after this? Yeah, sure. I've been recording, actually. Just in case anyone needs to look at it. Let me see if there's any problems in here that are hard. Because I'll go through maybe one question, give like a practical example. I remember I noted down which ones were hard. Let me see if I can find it. Give me a minute. Here you go. So the one I noted here, where is it? 32 on this one. Okay. Actually, let's not do that one. That one's going to take a while. There's 22, 13. Roots on a quadratic equation. Fuck, this one's easy. Man, I should have saved some like good questions for us to go over beforehand. Yeah, I think oh. Someone tell me what's wrong with this. I'm paying. How about we go over previous lab, because those ones also have good questions. And let's go over lab 4. It's already submitted. Nobody's gonna out me out for this one. So Pascal's triangle, right? Actually, is there another one I could do, because this one's weird? That one's the lab data. What? Can you do scan F1? Which scan F1 exactly? The big list? Oh, the employee list. Yeah, sure. Let's go over that one, because this one will also contain some information that you guys need to you guys need to remember. God, brain fart. Oop. Being able to read and write from files is could be something that they'll include on test. It was in the practice exam for the people who did show up to the labs, which is maybe 5 people. So, so let's go over how it is. So let's actually just delete this all. Let's start from scratch, and I'll show you the sort of thinking that goes into it. So, do I have the lab data here? Yes. Okay. So let's start with a thought, right? The thought is that we have a file which is a bunch of lines, and on each line is employee number, number of shifts, pay per hour, and then hours, etc. This is lab 4 problem 2. So let me open that up. You can see here, calculate the program in C program for the following yada yada. Calculate the weekly gross pay for a series of casual workers using these information. Right? So, so we have as many hours as the number of shifts. And then we repeat for several lines, and the thought is, how can we get the weekly pay of each employee? Yeah, I forgot. They take down these lab docs after you're done with it. So let me just copy and paste it. So that's the that's a question, and this is the data. Right? So how can we get the weekly pay of each employee? Really hard question if you turn this directly from this thought into C. This is actually incredibly difficult, which is why I think a lot of people screwed up on this question, had a lot of trouble on it. So first thought, let's start with some amount of pseudocode. Okay, let's start. So we have the employee. So let's start. Step 1. We get the number of shifts. Or actually, let's save the employee number. Right? Because we'll need that for later. And the second one is let's get the number of shifts. Because we know that the amount of hours after the pay per hour is the number of shifts. So we need to remember how many shifts there are in the first place. And obviously we need to get the pay. Hourly pay. Okay, now what? Well, we can get... Okay, let's just say, let's get the sum of these. So it's right here. Get sum of hours. Okay, so we now have all of the information from the data table that we need for now, right? And now step 5 is calculate the base rate. So the base rate obviously is pay per hour times hours. That cancels out, you get pay. Cash dollar, what I don't have. So, obviously, as we just wrote there, right? Our salary times the sum of hours is equal to our pay. So we can now do that hours times, or let's do pay is hours times hourly pay. And then if we look through the question again, you'll notice that it wants us to what do you call? If the total hours are greater than 15 but less than or equal to 25, there's a 5% premium on base wage rate. If that, so to simplify it, so it's saying if hours bigger than 15, less than 25. That's awful. 1 second. Bigger than 15, less than 25. The pay increases 5%. Obviously, we can't do times 5% because then that's just 5% of the pay. We have to do 105%. And then 7, if the hours are greater than 25. 1 sec. Oh, this one is less than or equal to. So make sure you have that equal to. You lose marks if you don't. Pay times 110%. And then now we have our pay. So we now have a simple pseudocode for how to get the hourly pay of each employee. So let's start coding this in C. So I'm going to move that to the right so that you all can see here. There you go. Actually, let's just hide that because we won't need that for now. And then open up our ID and start going to town. So we need to go, okay, so we get the employee number. So first of all, we need to open the file, right? So I hope you guys remember how to do this. This is fopen in, file name. Okay. So this is in. I'm probably going to have to print this out on a paper and remember it because this one is actually a little bit hard to remember. So you have file name. So I'm just going to get where I stored my data here. It's a little bit long. So that's where the file is stored. Comma. And then we have R. So this is R for read. And in is equal to that. So, and by the way, if you're doing write, it's W. So just remember that. R for read, W for write. So we haven't even started on the pseudocode, right? But we know we're building up to this. So we go in, F, what's it called? Scanf. So file scanf, right? In %d, and then we're going to store in some information. So we know the first one is the employee number, right? And we can open our data file. That's our employee number. So let's go integer employee number. Oh, don't forget the and there. See, that's an example of sending back the information through pointers. So in %d, employee number. So that's our first step. Our second step is to get number of shifts. So once again, that's just this simple number here. So fscanf in %d, and we're going to do and number of shifts. And we're going to create that variable here. Let's go through the third step. Turn that into C. Get the hourly pay. And once again, this one is right after. This one is not an integer. We're going to store that as a double. So double hourly pay. Copy paste. And then because it's not an integer, it's a double, we have to use LF instead. And hourly pay. We go through the next step. get sum of hours. And now we hit a little bit of a brick wall because we're sort of like, how do we get the sum of hours? Well, we take this, and once again, we repeat the process. So we have a bunch of numbers, which are the hours per shift, right? So this is hours per shift. And then we have the number of shifts. What is the sum? And we can sort of go, okay, well, we know there's 4 shifts, right? So we can go, okay, so step 1, for as many times as there are shifts, we go, we sum up the hour per shift. Sum up to what? Okay, so let's go define a number up here. Define sum, or hour sum. Okay, so we define this integer hour sum is equal to 0. Remember, we have to, I don't know if you remember from the very start of this, we have to define this equals to 0 because if you don't, then it's just going to grab whatever happened to be there, which is whatever your computer was doing with it beforehand, which could be literally anything. So we define some hours of sum as 0, and then for as many times as there are shifts, so 4 shifts, 4 times, we sum up the hours per shift in hour sum. Does comparing 2 pointers compare the value they point to or the address that they point to? That depends. So if you have 2 pointers like this, pointer A, and then you have integer pointer B, if you do A is equal to B, then yes, this will compare pointers because you're saying this is a paper on which we have some number written, and this is a paper on which we have some number written. If you compare these two, they're going to compare the papers. So if you want to compare the values, you're going to have to turn it into the variable. So remember, when you see star pointer, right? That means the number stored on the paper is equal to the number stored on the paper. So yeah, the pointers may be different, the variables could be the same. And likewise, if you just have 2 numbers and you do this, then yeah, they're just going to compare numbers because this is some value 5 and this is some value 6. At the same time, if you do AND, just pretend those are AND symbols. I don't know to draw AND. This means the paper that A is stored on. Oops. Stored on. You get the point. Yeah. So actually, A and B could be the same value, so 5 and 5, but they're stored on 2 different papers, right? So 2 papers, same value. So yeah, you need to be able to look at those values and just sort of translate it in your head. Whenever you see as the star in a statement, that means the variable on which it's written on, so on and so forth. So, sorry, back to the question. Here. So, what is a sum? We define ours sum is equal 0. for as many times as there are shifts, 4 for example, we sum up the hours per shift in hours underscore sum. So let's write that code. So when we want, so let's define hours.sum. So integer hours sum is equal to 0. And then we go for int I is equal to 0. I is smaller than the number of shifts, I++. So you might get a little bit tripped up on this thing. We can sort of simulate it if we want to. So we can go, okay, so I starts at 0, and the number of shifts is equal to 4. So we go 0, 1, 2, 3. 4 is equal to 4, so that doesn't count because we are doing that I is smaller than number of shifts. 4 is not smaller than 4. That's 4 times. The alternate way is doing I is equal to 1. Number of shifts is still 4, but you do I is less than or equal to number of shifts. Just stick with this one because this one is going to be far more often you'll be seeing it. And again, if you are concerned, is that actually 4 times, you can always draw it out. Feel free to simulate in your head. Can you elaborate what you mean by stored on paper with and A and and B? Yeah, sure. So if we have integer A is equal to 5, right? So when we write something down, it has to be written down on something, right? So behind the scenes, this is written on some piece of paper, right? And the computer memorizes this as some location. It's a long stream of numbers. The point is, we can just sort of think of that away as a piece of paper. And likewise, if we make another integer, integer b is equal to 5. And the computer will again store this on some piece of paper somewhere. So whenever we work with all of this stuff, we are going to be working with the number written here. So if we do a plus b, it takes this value written here. This value written here is equal to 10. You know, good stuff. However, when we say and, again, forgive me, I don't know how to write and, a, this and, we can translate this to English as the paper A is stored on. So that refers to this thing, the paper, not the number itself. Right? And likewise, if we do and B, like the paper. So before, we can do A is equal to B. This is true because 5 is equal to 5. But if we do and A is equal to and B, this is not true because they're stored on 2 different pieces of paper. So why use and? Okay, so this goes back to pointers. Why do we use pointers? So if we have this function here, so function whatever, and we want to, so let's say it takes in 2 numbers, right? Integer A, integer B. So we give it these 2 values, int A and int B. And what it'll do is it'll actually copy the variable over. So it creates 2 new, it copies over these 2 numbers, 5 and 5. So let's do, so afterwards, let's do in this function, right? This big box. Let's do A plus B. Let's define some new C is equal A plus B. Actually, let's do stupid simple. A is equal to 10 now, right? So A is equal to 10. So this overrides this value with 10. But because we only gave the variable, these original functions are not, these original variables are not changed at all. This is a new variable, 10. And so we can finish this, and afterwards we do A plus B, and we get 10 still. A is still equal to 5. Let's do 2 equals there. So, what if we wanted to actually change what was written here at A? This is where pointers come in. So instead of giving the number here, the number written, we instead do a pointer. So this is so this is no longer asking for a number. This is asking for a paper. So instead we give it what you call and A. So this is the paper on which 5 is written. So now we have the paper on which 5 is written here. And we can go here and we can write star A is equal to 10. So this here said, get me the paper A is written on. And this here says, get me the variable on the paper. So this takes this number here and replaces it with 10. So that's 10. And because we gave the paper, this is the same paper as this paper. I'm just drawing in 2 different locations. So this also becomes 10. Yeah, so let's simplify that. There's not many papers, there's just 1 paper. So we've now overwritten the value of A. So that's the purpose of this sort of paper and what's written on it analogy, right? It's a difference between telling someone what's written on the paper and giving him the paper himself. If you tell someone what's written on the dictionary and he rewrites the definition in his own head, it's not going to change what you think. If you give him your dictionary and he writes over what's written on that dictionary, now if you go read over it, it's going to say something else. So that's the whole point of pointers. So going back to his question, does that answer your question, Gert? Or is there anything that you're a little bit confused on? Yeah, I'm sorry. It's just pointers are overall a hard concept. So I would recommend take your time with it. Try redoing some of the questions. Try looking over it with this sort of thought process in mind. And slowly you'll get more and more used to it. So back to this question. So yeah, here we go. So we managed to turn. Oh wait, we were in the process of turning this pseudocode. It's just a way to write over a variable. Yes, it's a way to write over a variable from somewhere where you shouldn't really have access to that variable. So yeah, pretty much it's just a way to write over a variable. So this pseudocode, we were in the process of turning into C code. So let's go back to our code. We have our for loop. That's our step 2. For as many times as there are shifts. So int I is equals 0. I is less than number of shifts. I plus plus. And then we go that we take in the hour, the amount of hours worked here, as an integer. And we store into some variable hours. So we're going to have to define that. Int hours. And then we go hours sum plus equal hours. Oh wait, this should go after. Oops. And we've managed to turn our pseudocode into C code really easily. So let's just show that on 2 different sides. We defined our hours sum. And then for as many times as there are shifts, we sum up the amount of hours per shift in hours sum. That's what we did here. So for as many times, we took in the hours and summed it up. So now We've managed to do a single step. Oop. Oh my lord. Oops. All of this was just for this here. And so now we can continue on with the rest of our pseudocode.
I got a question.
Oh yeah, for sure, go.
All right, so when you take the employee number, as a note to read only the first 5 numbers of the file.
How does it know only read? Oh, because of the spaces.
I see. So
So,
every
yeah.
space it stops.
Yeah. So it just keeps on reading the number until it sees a space. It goes, okay, it's not a number anymore, and
Alright,
it
cool.
stops there. Yeah.
All right, thanks, man.
It's the same sort of thing. I don't know if you've seen it, but you can do fscan. You can do scanf. %d. Oop. %d, 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 and you can put in 3 numbers like 5, 3,
Oh
2.
yeah.
Yeah.
Thanks.
Don't worry. Yeah, I didn't leak. My lab 5 stuff. This is lab 4, so I'm just going over the lab 4 stuff. So.
All right, cool.
Yeah. So, we did step 4. Step 5, pays hours times hourly wage. Right, so we do hours sum times the hourly pay. And this is our total pay, so double total pay. And now we need to modify this pay for this stuff. I'm just gonna skip this part. You should be able to do that, just for the sake of time. So let's go printf all of this information. So we have %d, 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 %lf, which is our employee number and our total pay. Let's just f close in, just in case, return 0. All right, we're done. We run this function, and we get the employee number and the total pay. Minor issue, that's just one employee. There's a lot more than one employee. And so, to keep on going until we stop, we can use a function called end of file. Or file end of file. I don't know why it's called file end of file, but that's the name of it. So, we can now use a while, or let's do pseudocode first, right? So we go, hey, we're not done here. So we can go, okay, step 9, is it the end of the file? And if no, we are going to go all the way back up to 1. Otherwise, yes, continue down, finish. And whenever we have this thing that we want to do something as many times as possible until something isn't true, we use a while loop. So we go while, and then we put all of this information within a while loop. What is our condition? As long as we are not at the end of file. So that is the function that you will use if you want to know, are we at the end of file? So while we are not at the end of file, so that needs to be a not. So not end of the file. We run this. Oops, I forgot. New line. Bada bing, bada boom. So that is the entire process from start to finish of a thought turn into pseudocode. We have one step that we don't entirely know what to do. We turn that into thought again. We break that down to pseudocode. We turn that into C. And we go back to the start. We go back to where we were. And then we keep on turning it into C. That is a step process that you should be doing. It'll help you understand the question a lot more. Focus, I know who you are. You are going to be in big trouble. I'm joking. I'm joking. I appreciate the applause. Thank you. So yeah, I would recommend if you want to store some information, or you want to write some information on... Which one of you fuckers? I would recommend writing down all of the information relating to files. So that's fopen, fclose, feof, what do you call it? fscanf, the modes, reading to, writing to a file. So that's also fprintf. Because remembering function names is hard. I'm gonna be real with you. So I think that's pretty much it. Is there any other questions that anyone wants to like me to clear up? Because other than that, I think I'm pretty much done here. I'll see, because I was recording. I'll see if I can go upload it on like YouTube or something.
Do you know what BOFA is?
Yes, I know what BOFA is. BOFA your nuts! I gotcha.
Have a good day, bro.
Yeah.
Have a good night.
So, I think nobody else has any questions. So. Oh my lord, it's so long. Alright, well, I'll see you all. Good luck on the CPS and Ellie.